Good afternoon. Welcome to Mountain Minds Monday, a program of Tahoe Silicon Mountain. My name is Ellen Rayner. I'm on the board of Tahoe Silicon Mountain, and I'm welcoming you from a snowy Truckee, California, in the middle of a big storm. Tahoe Silicon Mountain puts on 2 monthly programs, Mountain Minds Monday, which has been going on for over 11 years now, a monthly speaker series. We also offer First Friday at 4, which is an entrepreneurs roundtable that is currently on hiatus due to social distancing requirements during the pandemic. This event does happen the second Monday of every month. We have not yet announced our topic for January. It's likely to be on fire science, but go ahead and subscribe to the YouTube channel so you can learn about it when we announce it. In addition to subscribing to the YouTube channel, you can get an alert when the new program becomes available, and you can go back and see some of our past archives. Join our Facebook group to engage with our community and sign up for our email newsletter. Really only 2 or 3 emails per month coming that way. We do ask for a donation of $5 for tonight's event. The best way to make that donation is to go to tahoesiliconmountain.com. In the upper right, there's a donate button. The reason we ask for that donation is because as an official 501c3, we do have some overhead. We're an all-volunteer board pictured here, and we're always looking for new members, both at the board level and other volunteer opportunities within the organization. We'd also like to thank our sponsors. Holland and Hart is our longest term sponsor. They're our gold sponsor. They're a law firm with offices in Truckee and Reno. They strive to lead their profession by giving the highest level of service and loyalty to their clients by forging a team, lawyers, paralegals, staff, and other professionals whose work is always another route to the top. This is where the spirit of the firm's pioneering and innovation began. We have 2 silver sponsors. One is Mobo Law, also a full-service law firm started in Truckee. Provides excellent representation in an approachable, responsive environment with a human touch. The firm is comprised of attorneys and support staff with integrity and a solid work ethic, providing exceptional work that truly benefits their clients. They love their work and it shows. Our other silver sponsor is Bare Knuckle Branding. It's a branding and marketing company based in Reno that helps your company develop a brand strategy that packs a punch. Bare Knuckle gives you the tools to pull your vision together with an unstoppable brand with a plan. When your business and branding are aligned, miracles happen. I'd also like to mention our community partners, Nevada County Tech Connection, Tahoe Truckee Media, the Truckee Tahoe Airport, Lyft Cowork Space, and the Truckee Chamber of Commerce. You too can become a sponsor of Tahoe Silicon Mountain, or specifically our Mountain Minds Monday event. So without further ado, I'm going to move on to the main event. And wow, we have an all-star panel tonight. The standardization of Alpine ski boot binding systems and shop practices has resulted in significant injury prevention worldwide. These successes first began with scientific methods of discovery to better understand how Alpine equipment works as a system, including the skier, and later how engineering designs and best practices might impact resolution. So we're going to hear a panel moderated by Heidi Ettlinger with ski industry experts Dave Carpenter, Dave Dodge, and Jasper Shealy, who've spent over 50 years studying snowsport related injuries. The evolving safety practices and innovating ski binding and boot designers. This presentation includes the work of Carl Ettlinger, who over the course of his lifetime became a distinguished researcher, discovering methods to reduce ski injuries, which led to the production of testing devices, training workshops, and videos to make skiing a safer sport. His collaborative research and resulting innovations have saved the skiing public from tibial fractures costing conservatively, by an estimated $600 million annually. Carl was recognized by the American Society of Testing and Materials, ASTM, with the honorary title of Fellow for meritorious and dedicated leadership of the ASTM International Committee F27, and for conducting the seminal research that provided the technical basis for standards that have materially improved skiing safety worldwide. Carl also received the Carson White Golden Quill Award for outstanding contributions to the advancement of snow sports by the North American Snow Sports Journalists Association. Please refer to our press release to read more information on the background, and we'll get into the panel. So I'd like to give a little background on our moderator and panelists. So Heidi Ettlinger served on the PSIA AASI National Alpine team from 2012 to 2021. She's a member of the PSIA AASI Women's Advisory Group, the Nancy Oakes Hall Scholarship Committee, the National Education Leadership Council, and the PSIA Western Division Education staff. Some of our locals may know her through that. Heidi has dedicated much of her career to building and leading women's adventure programs in winter and summer for the public and professionals, many of which have served as a catalyst for helping more women successfully pursue recreation and professional endeavors. Alongside designing and implementing training programs, Heidi develops products to recruit and retain new snow sports participants while growing her business, Gearing to Go. For several years, Heidi coordinated the ski and snowboard mechanics workshop, along with providing project coordination for Vermont safety research and administrative support for Vermont ski safety equipment. Now on to the panelists. Dave Carpenter is the North American Risk Manager for the Rossignol Group, as well as a member of ASTM F27, the Committee on Skiing, Snowboarding, and Cross-Country Skiing. Dave is the subcommittee chairman for F27.83 on international standards. He's the chairman of the U.S. Technical Advisory Group to the International Standards Organization on Skiing, Snowboarding, and Cross-Country Skiing, and has held that position since 1998. Prior to Rossignol, Carpenter worked for Trapper Ski Boots. He then became the technical service manager and product manager for GEZE ski bindings and risk manager for Elan Marnik, Dolomite ski boots, Look ski bindings, and Look cycle products. Carpenter began his industry career with the Mount Mansfield Company, Stowe, Vermont, and various ski and bike shops in the Stowe area. His history includes working with Vermont Ski Safety Equipment, Inc., building ski shop test devices and product testing for Skiing Magazine, and assisting with the Sugarbush Research Project, the longest running ski epidemiology study in the world. Carpenter, much like Dave Dodge and Jake Shealy, has had a close friendship with the late Carl Ettlinger and Vermont ski safety equipment since the 1970s. Dave Dodge is the owner and founder of Dodge Ski Boots. He serves as the ASTM subcommittee chairman on binding test procedures and has spent over 40 years on standards development with ASTM. Throughout the course of his work as an engineer, Dave has developed over 180 patents in worldwide snow sport, over 180 patents worldwide. Dave founded Composite Developments, where he designed and developed products for several snow sport manufacturers. Later, along with colleague Carl Ettlinger, he formed Vermont Safety Developments. VSD developed knee-friendly ski binding technology, including 2 patents. Prior to forming his own business, Dodge was director of R&D at Burton Snowboards and also worked at Rossignol as a design and quality control engineer. Dr. Jasper Jake Shealy retains emeritus status at Guidance Engineering and is an invaluable research for skiing safety knowledge and history. Dr. Shealy has been researching ski-related injuries for over 40 years and has published over 100 peer-reviewed articles on the subject. As the science overlord, he continues to play an active role conducting ski safety research with Guidance Engineering. So with that, I would like to turn the mic over to Heidi Ettlinger to introduce and moderate the panel.
Good evening, everyone, and thank you, Ellen. That was such an amazing introduction, and I'm incredibly honored to be here. A huge thank you to Tahoe Silicon Mountain for inviting us, and we are really looking forward to this evening. I'm going to go ahead and share my screen, and we'll get started with our presentation. So as Ellen mentioned, this evening we'll be talking about alpine ski binding technology, past, present, and future. And one of the things that I just like to call your attention to is that Ellen gave such an amazing background on everyone that's here this evening. And I just wanted to let you know that unfortunately Dave Dodge had an urgent family situation and won't be able to join us, but we will be covering everything that he put together for the presentation tonight. The background history of being contacted by Tahoe Silicon Mountain to speak on behalf of the subject this evening included an opportunity for me to reach out to my father's colleagues and to work with them closely over the past couple of weeks to put together an incredible presentation that will not only give you the history of snowsport innovation and evolution in binding technology, but also a history looking back at the injuries that were discovered, some of them resolved, some of them mitigated, and what's on the horizon for new technology that may be coming up in the next couple of years. The introduction that Ellen shared also included a bit about my father, Carl. And on the screen in front of you, you can see some of his favorite images. There's a great video I was hoping to have time to show this evening, so maybe on a re-invite, we'll pull that up. But in the lower left-hand part of your screen, there's a still image taken from the video at Smuggler's Notch. My grandfather was actually standing in the background with a clipboard, assisting my father while he gathered some of the first bits and pieces of data as he was working at the University of Vermont in his graduate degree program and taking a fond interest in ski safety. He would often remark to me that when my grandfather dropped him off to college, he handed him a bit of cash and thought he would join a local fraternity and put it to good use with networking within the school. And he promptly proceeded to figure out a way to get hitchhiking to Stowe Mountain, would invest that money in a season's pass at Stowe Mountain, and his relationship with the community and fellow Vermonters would continue from there. But there's much of the work ahead that we'll be sharing this evening, where my father Carl served as an integral role in building lifelong friendships that with the colleagues that you see here this evening, a few that aren't with us tonight, but a lot of the work came from his passion, his grit, and his perseverance, but mostly his interest in making snow sports in general and skiing in particular a safer sport for everyone to participate in. So I'm going to segue to introducing Jake Shealy, and I'm going to have Jake give you a bit of an introduction on how he came to know both my father Carl as well as Dr. Robert Johnson, also known as Bob, and where they first started to collaborate on the history of gathering snow sport injury research at Sugarbush, Vermont. Take it away, Jake.
Thank you, Heidi, and thank the Tahoe Silicon Mountain for hosting and putting this whole thing together. Wow, this really takes me back. I first met Carl while I was attending a ski mechanics workshop while I was a graduate student at the State University of New York at Buffalo in probably 1969, where my graduate work was master's was epidemiology of ski injuries. And the idea there was looking at ski injuries, not from a medical point of view, but from an engineering point of view. And the program that I was studying is really systems engineering. So in systems engineering, you don't look upon an accident as an accident. You look upon it as a system failure. That what about the system allowed or encouraged, perhaps, the mishap to occur, And what can we as an engineer do to help prevent that from occurring in the future? So, and many people think of ski injury research as being a medical issue, and it can be, but we engineers like to think that we answer to a higher calling. We're trying to prevent injuries, whereas physicians are kind of like mechanics, body mechanics. They put you back together and put you back in the field where you could get hurt again, but they do precious little to prevent that injury from occurring in the future. Now, Bob Johnson, on the other hand, even though he was a doctor, had this tremendous vision. And so I was very fortunate that in addition to meeting Carl at the ski mechanics workshop, the Buffalo State University North of Buffalo Ski Club, there were about 2,500 of us. We went to Mad River Glen and to Sugarbush for a trip. And while there, I once again ran into Carl and Bob and got invited to join the group because the work that I was doing meshed nicely with the work that they were doing. And so that began a collaboration, if you will, between the three of us that continued up until Carl's unfortunate demise. And I continue to do research now, hoping to continue following with the Sugarbush data, but working with an outfit called Guidance Engineering, located up in Seattle. So that's a little bit of my background. I became a member of, it was ASTM F814, which is now F27. And I joined in 1972 as a faculty member, and I've been working with them ever since. And it's been a wonderful collaboration. And I would just like to say, with my experience with Carl was just an amazing engineer. He had such an intuitive insight into things that oftentimes he would say something and I would think about it and I, well, that doesn't make sense. But I learned very quickly, don't argue with him, listen to him and think about it. And, more often than not, he was right. And so I learned to really appreciate his insight. And it was certainly his insight in terms of what we now call the phantom foot phenomena that led to the understanding of really what causes the vast majority of ACL injuries. And that work that he's been doing, or he did with Dave Dodge and with NSAA, has actually been very instrumental in cutting down on the number of ACL injuries, and I think holds promise that eventually we'll come up with a hardware solution. Carl came up with the knee-friendly approach, which was really sort of a software approach. It was teaching people how to avoid getting in a situation where you're likely to incur an ACL injury. Up till now, and as of now, there really is no good hardware solution to this problem. And that's something that we'll be talking about later in the program. So I think maybe that's enough babbling about background, and it's time to move on to the presentation itself. Heidi?
So Jake, before you unpack what's on the screen here, I just wanted to acknowledge that as we do move through the presentation, everything you shared about your work with both Carl and Bob originated from the Sugarbush Study, and it has become a very infamous study worldwide. And so although we're about to unpack sort of the history of what we've learned from binding design and the interface between the skier and their equipment, much of the data that we'll be sharing later on came out of that Sugarbush Study. So.
Absolutely. The Sugarbush Study is really the gold standard for ski injury research. It was the first really fully organized epidemiological prospective case study, to use all of the terminology, that started in the winter of 72, 73 and ran for almost 50 years. And we hope that we will still continue in some way to do that. But we have amassed a body of data that is unmatched anywhere else in the world. We have over 20,000 injuries that have been analyzed. We have about 10,000 controls, one form or another. We have the ability to analyze both injury-specific studies. For example, it was sort of a lark, if you will. When I became head of the Department of Industrial and Systems Engineering in 1990, the dean was berating me over the fact that none of my faculty had ever put in for a professional development leave, and he kept pestering me. And I thought, well, I'll put him in his place. I'll make a suggestion. So I put in a suggestion that I should go off for a winter and study ski injuries, thinking that, A, he would say no, and B, it would shut him up. Well, to my great surprise, he said, sounds like a good idea, because what I proposed was to look at what is the role of helmets in ski injuries. Are they a good thing, bad thing? Do they work? What's the evidence for it? And at that point in time, there was no evidence that helmets work. It just was something, well, it seems like a good idea. And I'll touch upon that briefly later on. But so there are many, probably easily a half dozen studies that have begun around the world that are all based in one form or another on the Sugarbush study. So with that, let's move on to our slide. And just a little quick historical overview here on this first slide. The 1940s, we had cable bindings and bear trap bindings. And generally what saved people was the fact that the skis were weaker than the bone. So that when you fell, there was a good chance the ski would break rather than the leg would break. The heel, the soft leather boot, there was almost no edge control. There were wooden edges, and not a great deal of performance. By the 1940s, we had cable bindings and bear traps, and people started to occasionally put metal edges on skis, but the bindings didn't release. And because of the soft leather boots, the most common injury was to the ankle. By the time we move into the 40s and 50s, we've gone from a simple wooden ski with soft leather boots. We now have higher, stiffer boots with bindings that promised to release but didn't. And then we move into the 50s and 60s. All of a sudden, we have hard plastic boots and skis made out of material other than wood. And so the ski was stronger than the leg, and the boot was no longer soft. And all of a sudden, instead of ankle injuries, we had an avalanche of tibial shaft fractures. And in fact, at one point, they were called Lang bangs, named after the boot, the Lang boot. Then we had Mitch Cubberley came along with the Cubco binding, which predates almost everybody in the audience, I'm sure. But it was the first sort of systems-based binding, if you will, and that Mitch recognized that there was a serious problem with compatibility between the boots and the bindings. And the Cubco binding got rid of that by having a metal interface, a metal attachment on the ski boot and a metal attachment on the ski itself, and that was the interface. And so we had a whole series of these kinds of bindings. And at that time, and this was about the same time I was doing my master's, those kinds of bindings, the Cubco, the Girch, the Spademan, they had the lowest overall rate of injury because largely they solved or resolved, if you will, the incompatibility between the ski and whatever binding you might have. And so we were moving forward. Next slide, please. So our innovations, as I've already stated, in the late 50s, we had at least 35 different ski bindings, and all but the Cubco and the Miller they were unchanged and for the most part since the early 30s, including generic heel cables, which in theory could release, but rarely if ever did. By the mid-60s, the plate bindings, especially the Cubco, and low friction devices invented by Gordon Light, came into play. And all of a sudden, we started to see the real promise of a releasable binding. And then Tyrola introduced the Click Rocket, which was a true releasable binding. Next slide. And so this is about the time that the Sugarbush study began. It's about the time that I got involved in ski injury research. There was research going on also in Europe. There was the IAS, a German outfit, and some research going on in Germany to figure out what it takes to break a leg. And at that time, the injury rate was very high, and the predominant injury was a midshaft tibial fracture, because now the boots were stiff, the skis were strong, the bindings theoretically could release, but rarely, if ever, did. And about that time, we started thinking about, from an engineering point of view, well, what is the problem? And the problem was broken legs. So what could we do to prevent them? Well, we had to first of all figure out how the legs are getting broken. And they're getting broken in bending, which was the result of a forward fall. They're getting broken in twist as a result of a twisting fall. And so that naturally led to the idea, well, if it would release at the heel on a forward fall, that might prevent that. And if it would release at the toe in a twisting fall, that might prevent a spiral fracture. And so numerous different designs came on the market, but very little progress in terms of preventing injuries, because while we understood the nature of the injury and therefore the problem, and we had a nascent solution to it, it didn't work. And so the question is, well, why doesn't it work? And we realized that there are all sorts of missing pieces here. We began to realize the work, particularly of Carl, the role of friction between the boot and the ski, between the boot and the binding. And Gordon Leip's work with the Leip slider helped to address those issues. Then, okay, so we've got a releasable binding, and so it's presumably adjustable. How should we adjust it? Well, it's sort of a Goldilocks issue. You want the binding to release before your leg breaks, but you don't want it to release when you don't want it to release. And so it could be too tight, it could be too loose. And so the question arose, well, how high can we set it before we break the leg? And the answer is, well, we need to know, what does it take to break a leg? And that's where the Germans came into play, breaking literally hundreds of tibias in very nicely controlled laboratory conditions, so that we now have an enormous body of data telling us how strong bones are. The other side of the question is, well, how low can we set the binding without having an unacceptable number of releases? And Carl, bless his heart, he and I worked together on a paper which we call the minimum retention requirement, where we encourage people to go through a course. This was before the days of informed consent, and before you had to have an institutional review board look over your work. And it's the kind of work that you probably wouldn't even be able to do today. And I'm happy to say nobody got hurt in the process of what we did, but we would randomly change the release value of a binding up and down to figure out, what is the minimum level we could set the retention without an unacceptable number of releases. And so all of a sudden, we had two parts, two answers. We knew what it took to break a leg, and we knew what it took to ski. And that became the basis really of the release chart that is used today. And Dave will be talking more about the release chart later. But in addition to all of that, we had other work to do. We had to figure out a boot design that was appropriately stiff, not too soft. So once again, sort of a Goldilocks sort of thing. And we had problems with the bindings. Many of the bindings had very rigid coupling. and did not allow for any sort of elasticity, shock absorption. And so the work, for example, of Dan Moat in particular, was very helpful in determining the answers to some of those questions. The next. And so what we see on the graph in the upper part here is lower leg injuries. And just a moment, because normally we think of progress and injuries with a line going down. And you can see here we have a line going up. And that's because what we're looking at is the minimum days between injuries, known as an MDBI. And if the number of days between injuries goes up, that's progress. And so that's why you see a line going up. And what we're looking at here is over about a 30-year span of time from the early 70s, that you can see in the first 20 years, that line goes up at about a 45-degree angle. And what we achieved was about over an 80, almost a 90% reduction in lower leg injuries. And that's the period of time when we standardized the boot sole, so that because you could think of the toe of the boot and the heel of the boot as a cam surface, and it's working in conjunction with the binding. And so the binding is a cam follower. So you no longer had to notch boots, you no longer had incompatibilities and so forth. So the boot binding compatibility issue was solved. We solved the friction problem. We solved the lack of elasticity problem. We had a boot that was better supportive, and we had a binding adjustment system that allowed for the binding to release before it broke your leg and would keep you in so you could keep skiing. Now you'll notice that the line levels off after about 20 years. And in fact, hasn't really changed a lot. I'll talk about a little bit more of it. But as we look at now this next slide, you can see on the left-hand side what I've just been talking about, the recognition of the role of friction between the boot, the ski, and the binding, the anti-friction device, the low friction, the incompatibility between the boot and the binding. So we had an ASTM standard. And this was the beginning of a whole series of ASTM standards that we'll talk about in a minute. But we improved the ability of binding to absorb impulse loads and impact testing. So that's what it took. Continuing on the other side, we can see the scientific basis for the retention values, which is ASTM F939. What should the binding be set at? And once we had a system, and you have to realize that the boot and the ski and the binding, the first time they came together to be a system was when they met in a ski shop. And so it didn't matter how well any one of those might be put together. It was when the system was put together that we needed to test it to make sure it worked as a system. And so that's the ASTM shop tested standard, which Dave will talk about. Now, if you look at the slide down below that, you'll see it goes up, which is good, and then it goes down, which is bad, and then goes back up. The reason for that little downward slide right there was an infamous device that was a very short ski that did not release. And it was perhaps the most efficient means of breaking a leg we ever saw. And that little device all by itself halted the progress until we finally sort of got rid of it. And so now we're back on the road to recovery. Next slide. All right, so we've reduced the bend injuries by about 80%. We've reduced twisting injuries by about 90%. And we're at the situation now where if you're doing alpine skiing, and Dave will talk about something else called AT, but if you're just doing ordinary garden variety alpine skiing, virtually all of the remaining tibia shaft fractures are potentially preventable by the inspection of equipment prior to the injury. In other words, if a good shop mechanic had a look at it, they could identify what was wrong with it. And when I was teaching engineering, I would use this as a case study. I'd say, this is about as good an engineering design success story as you could possibly hope for. And over here on the right-hand side, you can see a whole series of ASTM standards, which now, for the most part, have been incorporated as ISO standards. So the binding mounting area, where do you mount the binding and what does the ski surface have to look like? How do you test it? What's the ski boot specs? What's the binding setting? What's the specs for a binding test device? What is the ski shop practices? These are all standards that were developed by ASTM and are now part of ISO. And so our ASTM standards have made this success story possible with a lot of help from NSAA, which has supported ASTM present at ISO meetings. And as I will just repeat myself, virtually every relevant ISO standard relating to skiing and snowboarding originated within ASTM with NSAA's support. So the notion, and I've served from time to time as a defense expert on behalf of the ski industry, and one of the canards that is launched is that somehow the ski industry makes money off of maiming skiers. And I've never understood that as a business model. I mean, how do you make money maiming your customers? And it simply isn't true. And unfortunately, it isn't properly recognized in my humble opinion. Next slide. Okay, what have been the benefits? Well, as Ellen mentioned early on, by the late 1960s, the overall injury rate was about 4 times what it is today. It was running about 7 injuries, and these are medically significant injuries per 1,000 skier visits. Today, it's somewhere less than 2. You can argue how much less than 2, but it's probably about 1.5 injuries per 1,000 visits. And back in those days, 20% of those were midshaft tibia fractures, or about 1.4 fractures for every 1,000 days of skiing, which is about the overall injury rate today. Now, if that same rate prevailed, it would translate into about 60,000 tibia shaft fractures annually just in the US. And a typical tibia fracture cost about $10,000 to repair. And you multiply that by the 60,000, it's $600 million per year. And in fact, we only have about 2,000 per year, about a 97% reduction, or a savings of over $500 million in medical cost alone. And if you figure in the non-medical part, it's probably $1 billion a year. Who knew? Other success stories, well, the ACL awareness program that Carl and Bob and I have promoted, and Heidi continues to push, along with shorter skis, have cut ACL injuries by half, but there's still work to do, and hopefully new binding technology can help. Next slide. Okay, one last talk here. I told you about my success in convincing the dean that I ought to go off and spend a winter at Sugarbush studying ski injuries, and it wasn't just that simple. I had to have a plan, and so the thought occurred to me that this is around 1990. Helmets were just starting to appear on the scene, and the helmet utilization was in the low single digits. And we just, I can't believe how lucky I was to be there at the beginning. And so the thing that we decided we would look at were potentially serious head injuries. That is to say, a diagnosed concussion, a skull fracture, closed head injury resulting in death. These are the serious head injuries that a helmet should be attempting to address. And so we tracked the rate of potentially serious head injuries and the rate of helmet utilization at Sugarbush. And that's what you see on the upper slide, the upper graph. And so that green line going from lower left to upper right is helmet utilization. And over this 20-year period of time, from 1990 to 2010, it went from low single digits to more than 90%. And you can see the dotted white line is the potentially serious head injury rate. Now, something that doesn't immediately appear clear here is that if you look at just the first half, and if you were to run a regression line through there, you would see that there was no progress. There was a lot of variation, a lot of up and down, but no real progress. And finally, after the helmet utilization rate achieved about 50%, all of a sudden, the thing started plummeting like a rock. And we wonder, well, gee, why is that? And you have to think, well, this was not it was not what we would call an RCT, a randomly controlled trial. Helmet utilization is a matter of individual choice. And so who is more likely to use a helmet in the beginning? Who is the early adapter? Probably somebody who was safety conscious. And people who are safety conscious have a lower injury rate. And so these weren't the people that really, really needed a helmet. And not until halfway through, where wearing a helmet became pretty common. And in fact, if you weren't wearing a helmet, maybe you felt a little self-conscious. And we started, dipping into the other half of the population, which would be the risk takers. And all of a sudden, look at the progress we made. So the bottom line here is that wearing a helmet is the best way I know to prevent a potentially serious head injury while skiing. Now, the other side of it is, well, what about fatalities? Given that at least half, if not more, of all fatalities are attributed to a head injury, wouldn't you think wearing a helmet would help prevent fatalities? And the answer is, unfortunately, absolutely not. And so the question is, well, gee, why is it so good at preventing head injuries but not preventing fatalities? Well, the two scenarios are very different. Most head injuries occur from somebody just falling over and hitting their head on the snow surface. So they're falling through a vertical height of about 6 feet or so. And that means the impact speed on the snow surface is about 12 miles an hour. On the other hand, the vast majority of fatalities are the result of high-speed impact with a fixed object. And Carl and I and Bob did a lot of research to try, well, how fast do people ski? And most fatalities occur on blue square trails, nicely groomed trails, but on the edge of the trail, because that's where the good snow is, and that's where you can go fast. And that's where you can, if you get in trouble, go into the trees. And so people running into trees. And so the question is, well, how fast do people go under those circumstances? And the answer is the average peak speed on a groomed blue square trail is about 26 miles an hour. And I want to tell you, if you run into a solid fixed object like a tree at 26 miles an hour, you're going to need more than a helmet to save you. And in fact, what the helmet does is it makes a slightly better looking corpse because, the head doesn't get all splattered against the tree. So the bottom line here is, by all means, wear a helmet. It'll help prevent a head injury, but don't think it's going to save you if you hit a tree. So try and avoid circumstances where you're likely to run into a tree is the best advice I can give you. Okay, end of editorial. Next slide. Or am I done? I think I'm done.
Oh, just a moment, Jake. I think that Dave is going to speak next, and I really appreciate the amount of time you spent unpacking some of those slides that we worked on together. I know that it was important to us as a group that before we started talking about where the rubber meets the road with the equipment that you have, with what's on the horizon for the future, with things that you can do to be proactive in looking out for your own safety, to mitigate problems from the past that we've solved, that we've seen through clinical data and decades and decades of research, how much it has improved safety, to make sure that we keep those simple principles in mind. I know that there are already some questions in chat for populating about ski shops and what to look for from a service component. So we'll be addressing some of those at the end. But without further ado, I'd like to introduce Dave Carpenter. You may notice on his thumbnail image, it says Carp D. When you have this many Daves working together between Dave Dodge, Dave Carpenter, and a few others, Dave Dodge actually goes by Dodge, and Dave Carpenter goes by Carp. So we didn't bother to ask him to change his name this evening, but I'll let Dave unmute and get started with the slide that we have up right now.
Thanks, Heidi. Thanks, Jake. You just told everybody how old I am. The first bindings I owned were cable bindings, and I broke my ankle on them. And the second ones I owned were Cubcos. You indicated there was probably nobody on this call that knew anything about Cubcos. I do. Um, the importance of routine inspection and testing. I can't tell you how important it is to take your ski equipment, your skis and your boots, to a ski shop at the beginning of every season, at the very least, and have them do both a visual inspection, where they're going to look at your boots and your bindings and confirm that they're compatible. And you're going to ask them to do a test with a mechanical testing device. And there is a complete distinction between those two, because if you only ask for a inspection, they may consider that only a visual inspection. And so that's why you specifically have to ask for a mechanical, have your equipment tested with a mechanical testing device. And that's becoming more important again today, because of the plethora of boot binding interfaces that are out there. And the equipment is changing yearly and rapidly, and ski shops are bombarded by information from the manufacturers. And so it's really important that you do take your equipment in every year at the beginning and have them inspect it and go through the process. How the shop practices and standards influence the ski industry. Shop practices have done a great job at reducing the risk of injury, and it has done a great job at helping shops be able to defend themselves from skiers that are injured and may believe the equipment was the reason that they were injured. I think you can go on to the next. Oh, go ahead.
Dave, before we go to the next slide, I know you and I have had a lot of conversations, especially over the past 2 years, particularly last year. A lot of people were walking from the parking lot to the resort rather than booting up in the lodge. But there's a lot of things that people can do today to visually inspect their own equipment throughout the season, especially if you find yourself hiking from a parking lot in lot D and you're on your way to the slopes from there. When you're looking specifically at the boot sole and your AFD, could you just acknowledge those two factors and how critical they are and how the boot, the binding work together as a system, and just something as simple as being aware of worn boot soles or a scrubbed up AFD can mean for the whole system working together?
Thank you. And it is a system. Most people think of it only as being the binding. And the boot actually has probably more to do with the performance of the system than the binding does. And Heidi's correct. Every ski area is a little bit different. And that walk from the parking lot to the ski area, you could be walking on snow, you could be walking on mud. I see people who are walking through, mud and gravel and that sort of things, and they step right into the binding. The performance of that system is significantly degraded because you're not looking at interfaces that are standardized. You're looking at dirt, and it's pretty amazing to me to look at equipment that people have been hurt on where they've never cleaned the boot binding interface, and they've put gravel on those what should be low friction interfaces that are now high friction interfaces. And it can do many things to the system. It can contribute to non-release, or it can contribute to inadvertent release. And so the inspection of the boot sole shouldn't even be, or the inspection of the equipment shouldn't even be limited to just the shop. You should be doing it each time you step into your binding. And at the end of the day at home, there's really would be a good idea for you to actually clean the boot sole. And I say that and people kind of scratch their head. And sometimes when I'm dealing with shops that have testing issues and I say to them, take the ski boot over to the sink and wash the boot sole, and they kind of think I'm nuts when I'm saying that. And I'll actually get them to test it and then clean the boot binding interface and test it again. And the shop technician will be kind of startled because it may not be even visually evident, the contamination. One of the other potential panelists for tonight actually did a study and had the interfaces analyzed with what was on those, and it was pretty amazing because there's lubricants from cats, there's contamination from cleaning agents, there's all kinds of things that could be on that boot binding interface, and you're attaching that system to your leg.
Yeah, so I really appreciate you covering that, because I know, again, in the chat, there's some questions populating about wearing cat tracks. And so part of the reason for having Jake introduce some of these prime things that were discovered through years of research and careful tracking of the data was that anytime you do anything to the boot sole and or the AFD to increase friction, you've now substantially increased the risk that the binding is not meant to, or isn't functioning as it should as a system. Before we go to the next slide, a lot of people are probably wondering what shop practices are. So, we like to think that when people within the standards committee work together to implement shop practices, that created some consistency from shop to shop. So maybe it would be great to know just a couple of quick points about what was in the shop practices, so people know across the board, consistency wise, what you can expect to go into a shop as far as things being implemented for their knowledge of both a visual inspection and a testing.
The shop practices was actually pretty interesting because it really started in the 70s. The US was the first country to actually deal with shop practice standards, and that was the testing of ski boot binding systems by the shops. And that standard was started in the 70s and didn't pass until 1987. It was 17 years before it was passed. It was a very long process. Basically, it's a requirement by shops whenever they assemble a retail system or make an adjustment to it, that they test it with a mechanical testing device. And there's a specification for the performance of that system that the system has to operate within. And if you read the inbox instructions that came with your bindings, it says you should get your system tested at the beginning of every ski season and also every 30 skiing days, or anytime you make a change, any sort of an adjustment to that system.
I think that's a great segue to what this is in terms of looking at some of the devices that were created to better look at this whole function of testing.
So the machines that you see on the right is a ASTM F504 machine that was developed by Carl Ettlinger and the late Dr. Eugene Bonnick from Case Western. And it is an upside down leg with a transducer to record the loads that the leg would feel. And we can recreate certain skiing situations and record those values, and we can create a release retention envelope that you see on the left. Again, this machine, the 504 machine, was developed in the 70s, was used by the Sugarbush Study, and they, at the Sugarbush Study, any skier with what was described as a LEAR injury, and that's a lower extremity, potentially equipment-related injury, their equipment would be tested on this 504 machine. And we would, the Sugarbush Study had a orthopedic surgeon on staff who could specifically diagnose the injury, and that injury could be compared to that release envelope on the left-hand side. And every boot binding system has a slightly different release envelope. And like I said, with a LEAR injury, a lower extremity, potentially equipment-related injury, we could see in that envelope specifically where there was an issue with the performance of that injured party's ski boot binding system. And this led to an amazing evolution in the ski equipment. I'm going to go on, or
oh no, you can. I just thought it would be interesting because I know that the evolution you're gravitating towards will be this screen here. So
one point I wanted to make is Dr. Ettlinger was one of the editors for Skiing Magazine at that time, and the binding editor, and he was able to take the information from the Sugarbush Study and write articles on ski bindings, and Skiing Magazine actually printed them, and it tended to weed out bindings that may not have been that adequate. They specifically told the good ones from the bad ones, where most magazines aren't going to come out and say those types of things. So on to the next slide. There was a discussion about charts, and when you go to a ski shop or any place, you may hear the word DIN thrown around quite a bit. And in the late 70s, early 80s, well, let me back up for 1 second. When I first started working in a ski shop, if I were to adjust 3 different bindings just for myself, 3 different designs of bindings, I would set one on, let's say, a 3, because that's what the manufacturer said. And another one I would set on a 7, and because that's what the manufacturer said. And the other one I would set on a yellow or a blue, because that's what the manufacturer's chart said. The DIN standard, which is a German standards organization, developed a production standard for ski bindings, commonly referred to a DIN setting. And it had a specific sole length, specific indicator value, and a specific tolerance. And then along came, let's say we were in the 80s, let's say in 1987, we agreed to a common format table. And that's what you're looking at right here. It's this chart that ski shops use complies with ASTM F939 and ISO 8061 and 11088. They really have, since about 1986 or 87, they've had nothing to do with the DIN. But still today, you commonly hear people refer to DIN settings when they're really not DIN settings.
If you don't mind, Dave, just answering the question, you know, when we look at what is a release setting, and you hear about people using the word DIN and maybe sort of refreshing their vernacular to be able to use the appropriate terms, might also help themselves, their neighbors, and anyone who's either borrowed equipment, found something in an attic, taken a whole bunch of stuff down to a shop and asked them to put a whole system together. And the relevance of actually how your binding release setting is calculated is quite critical. And we know that going back to the research that Jake shared. So, so the chart is actually imperative that you both understand how to classify yourself and determine a release preference. But it's equally as important to recognize that just because someone may be skiing on a different ski setup, you might think that you're the same size. Their binding is set on a 6, your bindings are set on a 6, so you automatically assume you would be fine just hopping into their equipment. And I know typically the advice for that is to take it to a binding mechanic, a certified binding mechanic, and have them just make sure that that is correctly set up for all of your unique characteristics.
And I think it's really important to enforce this, or because when you go to somebody's garage and borrow some equipment, you really don't know anything about that equipment, and you don't know simply how long it's been sitting there. And the part about testing it with a mechanical testing device, ski bindings are like a little motor. And so if you put your equipment away in April, just like imagine if you parked your car in April and then you didn't use it until November or December, and you got into it and turned the key, the engine might not run very well. And so here you are attaching a little motor to the bottom of your boot and your leg. And so it's really important, you know, when you're borrowing equipment, or that you actually take it in to a shop, ask for a inspection with a mechanical testing device, and it will confirm the performance, but it will also get that little motor working again, and it redistributes the lubrication inside of the binding. And so it's really important to do that. And just stepping into the fact that a boot will just fit into the binding is not good enough. And especially today, a lot of people are stepping into Alpine bindings with AT boot soles. They may fit in, but that doesn't mean they work. And so we'll segue into the next one here. My life was pretty simple up until about 15 years ago, because there were Alpine boots and Alpine bindings for 90% of them. And all those boot soles met the same standard, and they all interfaced with Alpine bindings very well. And then along came Alpine touring, and people liked the way Alpine touring boots fit, and they were a lot of times much more comfortable than Alpine boots, and so they were surprised they fit right into the bindings. That doesn't mean they work. That doesn't mean the system works to the same specifications. there has, again, 15 years ago, all Alpine boots met the same standard, ISO 5355. Now, with the advent of AT soles, there are many, many, many different types of soles out there, and not all compatible with Alpine bindings, even though the boot will fit into the binding. This chart on the right, there's so much, so many boot soles being developed right now that the ski shop receives probably 4, 5, 6 charts like you see on the right, different ones, different compatibility charts from different manufacturers. And so, again, it's really important that you go to a trained professional and not just somebody with a lot of experience, because the compatibility charts that you see are derived from laboratory tests and not those from a shop. And that starts the inspection process. The first thing the technician's going to do is look on the chart and see whether your boots are compatible with either the binding you just brought in or the binding you want to buy. That's going to be the first step that they make. So it's really important to go back to the shop each time. These pictures to the bottom left, there's these pictures were taken in lift lines, and in each one of these pictures, there's an incompatibility issue. Probably because the skier, took the equipment and stepped into the binding and say, oh, yep, they're adjusted, they'll work just fine. And again, the top left, the Alpine systems, Alpine boot, Alpine binding. We moved to touring systems and to tech systems. And so there's a lot of issues that didn't exist 10 to 15 years ago that exist today. And they're really only determined by ski shops.
And so, Dave, I'll just sort of clarify for the audience listening in that when the word issues is mentioned, problems that were resolved in the way that we looked at standard Alpine bindings and standard Alpine boots, we have new problems today to solve. And this chart was an attempt to solve some of them by improving the compatibility issue between a boot sole and a binding and how that interface reacts when you want your binding to part ways or your ski to part ways from you. And so, that simply doesn't happen as reliably if it's not compatible, and therefore the importance, because there are so many different types of combinations now, that it's a pretty simple thing to do to avoid injury, to bring your gear to a shop and have it inspected by a trained professional to make sure that the system is compatible.
Yeah, and it's release and retention. It's both of those things. Because there are certain risks by inadvertent release as there are risks with non-release.
Right. The segue we have coming up, and then when we're through this next segue, to talk a little bit about the work of Dave Dodge, and I'm going to invite Jake to unmute and join Dave and myself. But we have a few slides just to share what Dave put together with the three of us for tonight's presentation. And then I've been watching a couple of the questions populate in the chat. So thanks for those of you who have stayed over an hour with us. And we're looking forward to getting to as many of those questions as we can. But the goal of this evening was to give you a thorough investigation into the history of better understanding how much of the safety and the ability to look at participating in snow sports has become a much safer sport. And then through the lens of what's actually happening now, and how can you be safe and encourage your friends and colleagues to be safe simply by following some of the best practices that we learned through years of data collection and research. And the piece that we'd like to share now from Dave Dodge is looking ahead to the future. And so on the right-hand side of your screen, that's simply an example of looking at what engineers do best. And Jake acknowledged this at the beginning. And engineers look at problems. And then they look at not right away solutions, because sometimes it takes quite a bit of time to analyze what the problem is. And we thought that that was a great way to look at the mind behind Dave Dodge. I know that Ellen gave him a very nice introduction, and you're looking at part of that on your screen right now. But through all of Dave's work, I know that he's extremely proud of some of the research he did, particularly with Carl, and utilizing the fact that the Sugarbush Study, along with Carl's work, identified the mechanism of injury for serious knee sprains. So I'm just going to pull up this screen, which looks at some of the design patents that Ettlinger and Dodge put together. And this is a particularly interesting patent because it not only addresses some of the root problems that continue in the evolution of improving how bindings function, but it also nicks on a pretty interesting topic that I know a lot of advanced recreational and professional skiers encumber, and that's inadvertent releases. And so a piece of this patent addresses inadvertent releases, but I'm going to turn this over to Jake and Dave to just mutually discuss what we're looking at on the screen here to better understand some of the innovation that's out there.
Thank you. Well, it's unfortunate that Dave Dodge isn't here, so he could really explain what all this is, but we'll give it our best shot. This particular slide points out two existing problems with current systems. One, which we refer to as the sub-near point, and the other one, which is the bow effect. The sub-near point is a situation where the load comes up almost at the toe of the boot, and consequently, the heel never gets the message that it's time to release. And so that is a failure to release. The lower graphic is one where the system thinks that it has a message that it's time to release when in fact it shouldn't. And so it gives rise to the inadvertent release. And the lower one, I don't care how high you set that heel, there's a pretty good chance it's still going to come off if you encounter the particular situation that gives rise to the bow effect. In particular, think about somebody running a slalom course and running into a rut and driving their knee and their boot forward. That creates a situation where the heel binding is almost certain to release, even though there's no bending effect at the tibia. Dave, you want to add to that?
I think you've pretty much covered it. Yeah, I think what you see in skiing is some skiers having a bow effect release and automatically thinking they have to turn up both the toe and the heel.
Yep.
When in this situation, it's not really going to change what happens with this ski releasing. But what it does do is it puts you at risk of setting the system too high. And that's why it's really important that an issue that Carl told me years ago, saying, it's just, you can't reset the binding based on one inadvertent release, because you don't really know that it was inadvertent. It may have, there are many things that occur, and so you really shouldn't just experience an inadvertent release and automatically start turning the settings up. because you won't change anything.
Yeah, many of the so-called inadvertent releases are appropriate. And then the lower one, the bow effect, is particularly something that aggressive skiers and racers will encounter. And they will blame the binding when in fact it's something the binding just is incapable of addressing. And no matter how high you set it, it ain't going to solve the problem.
And you hit on a very good point, because it's very aggressive skiers and racers. The incidence of inadvertent release is very low today compared to 20 or 30 years ago for a number of reasons, including the mean age of the skier. And now it's, back in the 70s, the mean age of the skier was 20, and now the mean age of the skier is over 40. And skiers over 40 aren't quite as reckless as 20-year-olds because they have to go to work on Monday morning for the most part. And so they're much more conservative skiers, less of a risk taker. And so the incidence of inadvertent release is significantly lower today than in the 70s.
Before I segue to Dave's next slide that he put together for us, there was a question that came up in chat, and I thought it would be relevant to sort of address that now. And that's when we look at the longitudinal flex of a ski, I guess you could compare that to the torsional stiffness of the ski. But when you take those two bits of information into consideration, how does that impact the performance of the boot binding interface? And I think that that's important, because there's some great pieces that Vermont Safety Research put together where they talk about separating hardware from software and understanding why you may have had an inadvertent release. So maybe the both of you could just address that briefly in understanding how your equipment might be involved.
So I guess I'll start out, Jake. I think you hit on a very good point in that, if you look at the properties of skis 30 years ago, they were significantly more robust and stiff. And today they're wider, they float better, but they're softer. And so when a skier is out there skiing, the ski flexes significantly more than it did 20 or 30 years ago. Every time you flex the ski, you drive the heel piece back. And when the ski counterflexes, the heel piece comes forward. And if you look at the fact that the skis do flex and counterflex significantly more, you have more of that heel piece moving forward and back. And if the heel piece doesn't stay with the boot, when it counterflexes, it comes off. You have an inadvertent release. And setting the indicator settings higher isn't going to change that situation at all. I don't know whether you have anything, Jake.
No, I think you summed it up. You're much more into the ski technology than I ever was.
Just going to pull up that second slide that Dave shared with us, and I'll let the two of you unpack where this probably addresses one of the more serious but one of the more interesting facets of this evening's presentation, and probably arguably the most prevalent in terms of the amount of time and money spent to recover from a serious knee sprain.
Dave?
Well, maybe you should start with the recovery from an ACL injury, although maybe the audience is well experienced with that.
I think many of them probably are.
Yeah. I will say that, there is a lot of development going on in bindings, and this is to address knee injuries. But I think you said earlier, Jake, there's been no documentable success in that at this point. I'm not sure that was the term you used, but this patent here is one way to address it. The difference between this and ski bindings out on the market today is the toe piece and the heel piece basically communicate to each other, and that's different than what's out on the market today.
I know in my discussions with Carl and Dave Dodge that they oftentimes referred to this patent and this innovation as being a smart binding for, primarily for that reason. And it was through their research in really taking a deeper dive into what they knew about the loading of the inside edge of the tail of the downhill ski, and then the resultant forces throughout the ski and how the binding interprets that. And one of the critical points that I think people leave with this evening is that the binding doesn't know your home address. They don't have your cell phone number. They're not a telemarketer that's going to reach you. That binding is only reading a handful of critical information. And although innovation and evolution of design has come a long way, the binding still has a very difficult time understanding or reading the forces that create serious knee sprains.
Well said.
Yeah, well, just final, what you see on the right-hand side are some of the ways in which ACL injuries can occur. And this binding is designed to address those particular loading situations. And Carl and Dave came up with a very complex way of dividing it up into quadrants and coming up with some graphics that were mind-boggling, to say the least. And we toyed with the idea of displaying them, but neither Dave nor I felt comfortable trying to explain what they really meant. And I think this sort of Reader's Digest version is about as good as you can get. That these graphics on the right are really part of the ACL awareness program, which sprang from Carl's observation of how do you get an ACL injury. And so the next step was, after analyzing what is the injury and what is the cause of the injury, how do we address it? So that's the third step, which is to come up with a potential solution. And we're now hopefully about ready to enter into the fourth step, which is to see stuff on the market and ask the question, well, does it work? I mean, we certainly hope it does. And this is currently, I would say, the holy grail of the Alpine skiing business is the ACL injury. That is the injury. It's roughly 20 to 25% of all medically significant injuries today. And we're still looking for a good solution to it.
There was a question in the chat about our smart bindings using sensors and micro processors under development. And I would just add that this, the patent that you're looking at on the screen, you can certainly pull up online, and there's a deeper dive into the components of how this binding works. And in reference to it being a smart binding, unlike having a smartphone, this binding interface, the smart piece just simply refers to the fact that the heel piece and the toe piece are communicating. But if you have a closer look at the patent, there's a little bit more specifics to how that communication is occurring. Dave, did you have anything?
It's a mechanical, not a digital device at this point.
Yes.
The industry has been working on some sort of a smart binding that is digital for 40 years, I think. And we have yet to come up with a solution that is sufficiently robust to be able to handle the environment in which the binding has to operate. And, you know, we're getting better and better with our digital devices, and maybe one of these days we'll have it. But currently, this is, I would say, a really good mechanical effort at it. So it's analog, not digital.
There's a few other interesting questions. This is sort of getting back to having a deeper understanding of how your binding understands who you are. And the question is, are there any gender differences in the chart, meaning the chart that we looked at earlier with Dave on the release settings?
There isn't. I'll steal a line from Jake, I think. Mass is mass. Was that your line, Jake? Or was that Carl's?
Well, I probably was Carl's, and I stole it from him. But the issue of gender has been addressed, and we certainly took that into consideration when we were putting the chart together. And when we did our minimum retention study, we had males and females. We had big people, we had little people, we had young people, we had old people. So we sliced and diced it every which way we could, and we did not find any gender effect with regard to the minimum requirement. On the upper limit, there is a slight gender difference, but it's not big enough to warrant making any change in the chart, in my humble opinion.
Excellent. I'm just scrolling through a couple of, for those of you who are still viewing tonight, I am looking through the chat and there's a few questions getting handed over. So if there's something that I can forward to the panelists, I'd be happy to do that. There's a question about the benefits of wearing cat tracks, and I think we answered that earlier when we talked about just small amounts of wear and tear on the boot sole can make a huge difference on that critical interface. There's another question about you saw the benchtop reference manual for Alpine bindings inspection and installation, and is that suitable for homeowners? It was a manual that was designed for attendees at the Ski and Snowboard Mechanics workshop. It is a manual that is still for sale through vermontskisafetyequipment.com, but the intentions of that manual and putting it together was certainly for shop owners, but in general, it's a good guide, and it may share some information with you to better understand what the rental shop technician is actually doing. There were a few questions early on. There was one question about what current research is likely to have the most impact on safety, function, performance, compatibility. And that came early on in the presentation, and that may have been during the time when we were presenting on the research in general. I don't know if this is a helpful segue, but a lot of the research that determined a few of the problems and guided both standards and best practices to resolve some of those problems are almost being mitigated a second time, just as we have a new evolution of new boot binding interfaces. And that's probably one of the deepest discussions right now, is just making sure that we don't lose sight of things that we learned in the past, and that those practices can be considered when we're looking at evolving equipment or innovating much of the equipment, and the interest levels now for the number of people who are choosing to purchase different types of boots for a different purpose and a different experience out on the mountain. And Dave or Jake, I don't know if you have something to add to that component of current research and where that is most likely to have an impact on safety.
Well, I would say with regard to alpine skiing, the big issue today is still the ACL injury. And I think the research component is pretty much done. I mean, we understand the nature of the injury. We understand how it occurs. What we're lacking now is a sufficient solution to that problem. but at the very same time, it looks like we're going back and sort of reinventing some of the problems from the past. I mean, prior to us having a chart and a unified setting system, we had compatibility charts that were bewildering because each binding and each boot represented a not necessarily unique, but a different set of circumstances. And you really needed to have a very skilled ski shop technician to be able to make most bindings work with most boots. And we largely solved the problem. And now it looks like we're backsliding back into a situation where we have this plethora of compatibility charts that are just absolutely bewildering. And it's the same very problem that we addressed way back in the 60s and 70s with Alpine skiing, and we solved it. And now we're back kind of where we started, almost.
On the note of compatibility, there was a question about whether or not work was underway to standardize backcountry AT, randonnée, and pin binding systems for backcountry use, if there's any work underway considering that.
Okay.
There's always research looking at the compatibility of different interfaces. And I don't know how to expand past there. There's research going on both in Europe and in the United States on compatibility.
Great. I'm just doing a quick scan here to make sure that there isn't anything else that we've missed in the chat. I know that it was a sincere honor of mine to be asked to look at this subject, and an even greater honor to reach out to people I've known for nearly my whole lifetime, who have spent their lifetime invested in the welfare of everyone in snow sports. There's a number of resources that we included in the presentation this evening, and I'm looking forward to compiling those to create a last page to our slideshow this evening. That's a bit more of a reference document with hyperlinks on where you can find additional information or details on what we presented this evening. And I'll be giving that to Ellen and the folks at Tahoe Silicon Mountain to be able to compile into a PDF that will either live where this live recording will be or on their website. I'm going to open this final closing up to Jake and Dave, and to see if they have any parting thoughts that they'd like to share with the viewers this evening before we wrap up.
Maintain your equipment and go to ski shops and have them inspect your systems, ski boot binding systems.
Okay. By all means, buy, wear, use an approved helmet, but ski as if you weren't wearing a helmet, because it's really interesting. The behavior of people with and without helmets is somewhat different. Carl used to talk about, imagine football, where there was a rule that in the first half you wore a helmet, the second half you didn't wear a helmet. Would the play be different? And the answer is absolutely yes. The helmet is an enabler in the sense that people will ski somewhat more aggressively. Fortunately, the benefit of the helmet outweighs the risk compensation in this particular issue.
Thank you. And thanks again, Ellen, for hosting us this evening. It's been a true pleasure of mine, and we're all greatly appreciative of the opportunity to share what we did tonight.
Thank you, Heidi. Thank you, panelists. We're so fortunate to have had you with us this evening. And to our audience for sticking with us, and whether you're watching live or watching the replay, we hope you'll be back with us on January 10th, the second Monday of the month. It's always when we do our Mountain Minds Monday presentations. Thank you all.